Okay, now so today we're going to learn about incident matrix. Incident matrix is basically a 2D graph of relationship between each nodes in a binary tree, something like this. So in this case, it's way different from adjacency matrix. In incidency matrix, each columns becomes edges, okay, and each row become nodes. So in this case, this is directed graph and this is undirected graph. You will ask the reason why. Well, there is -1 and +1 and a 0. So in undirected graph, it basically only point we only type the numbers for the relationship between each nodes in each column. So the column is node, so that's why we have to put it directly above each node, right? So we can have more flexible way of uh, less edge or more edge. In it doesn't have to be balanced with the rows. So we can have like 4 rows and 5 edges, or 5 nodes and 4 edges. So it can be very flexible. So that's why we also have a directed graph. So directed graph basically is something -1 and +1. -1 represents something that uh, going out. So for example, node 3 is related to node 7 and we are entering. So which is why we can say that this is 1, +1 going that way, right? So for 7 to 3, it has to be relationship. So we're pointing back, so that means -1. It's in leaving basically. So something along that line we have to uh, put it that way. So in this graph, directed graph, um, node 1 is related to node 2. So node 2 is entering to node 1, right? So if you look at this, we're not concerning about uh, the column number anymore. We're just concerning about directly above of each node. So this node 2 have to be directly above node 1 in order for them to relate it to each other. So node 2 is entering to node 1 and node 1 is leaving node 2. So -1 for node 2, +1. So very different from adjacency uh, matrix. This is incidency matrix, and in this case is undirected graph. So in this case we can just say they're related, right? One to one, right? And we don't have to do anything right here. So this is more of directed graph. So we've been talking about for a while. All right, and the challenge asks us to implement undirected graph based on basically I think graph should have weights and edges, and okay, this right here. So 5 nodes have the following relationships. Okay, so we will have 5 nodes. Let's implement that. So and 5 nodes, and I think so that we will have 5 nodes and 4 edges. I think that's what it is. The challenge asks us to do. Undirected graph with 5 nodes and 4 edges right here. Okay, so let's use this. So 1, 2, 3, 4, 4 nodes. All right, we don't have a relationship yet. So let's type that. So that's the first node, second node, third node, fourth node, and 5. Okay, and then the first and the second nodes. The first and the second nodes. Okay, and then the second edge will be between the second and the first edge is between the first and the second edge is between the second and third. Okay, so second and third. Okay, see that very different from adjacency matrix. This is so in incidency matrix, basically they have to align. The third edge is between third and the fifth node. The third edge is between the third and the fifth node. Okay, so in this case, we can use the third right here, right? So because it's already taking over here, we have to move it down, and the fifth node. So see that? Third and fifth, okay? And then the fourth edge is between the fourth and the second node. The fourth and the second node. Okay, so fourth and then the second node right here. Okay, so see that? So in this case, if we put like one right here, then it just basically blocked. So they have to be free around here. Zero. It has to be 0 between these edges. Okay, unless they are related, we can't just type it to 1 right here, right? So, or maybe. So let's try this first. Control and enter, and it worked perfectly. And let's see if we can, you know, hey, make sense of this. Like, for example, the is that the fourth edges between the fourth and the second node, right? So the fourth and the second node. Oh, okay. If we put number 1 right here, then that will be like third and the 2 node, and this right here. So they have to relate it to each other. This positions right here. Well, they do relate it right here. So apparently we can't run. We can't say that if we push this. So they have a common number, but what if we can just like do it like, you know, put the number right here and then put the number right here. Just rely on this number and just put number right here and 0, 0. It doesn't work out that way, unfortunately. It just basically have to be, you know, a clean relationship between each node. All right, so that's it for our adjacency incidency matrix. Okay.